So this video is about looping over multiple iterables at once in Python, and often we have to loop over iterables at the same time. So I'm just going to jump straight into the actual code, and I'm going to take some code that I've extracted from the web, which is kind of like just a list basically. So I'm just going to copy that and paste it in here. And also I'm going to take a list of colors. So that was a list of fruits, and I'll take a list of colors, the first of which two fruits look rather exotic, but I'll work with them anyway. And basically what we're going to do is just loop over the fruits. So I'll just put a little comment here. We're just going to do a simple loop to start with, loop over the fruits. And this one's quite an easy one because all we have to do is a for loop. So for fruit in fruits, very common pattern in Python that is, for fruit in fruits, and then we'll do a print of the fruit. Just like that. We can use the autocomplete, and it's very fast and we do it. And what we see is we loop over this list: locat, jujube, pear, watermelon and apple, and each one of those gets printed out sequentially in our list. So that's all fine, and that's the basic ethos of Python. So Python makes it very easy for us to loop through an iterable, and in our case the first one was the fruits iterable. Now let's move on from that, and we're going to use nested for loops now, and let's see how that actually works. So I'll paste in this little comment for nested for loops. That's what we're going to use. And one thing that we will observe, or we can see, is that these lists over here, and actually even the last variable, the last iteration of fruit in fruits, which was apple, will be stored in the memory. So because we've run it, so if I do in fact we can see our variables here, our Jupyter variables. We can see this is our list of colors: brown, orange, green, pink and purple. We haven't actually used them yet, but we've created them, so they're in memory. And here's our list of fruits, and finally the last item in the list, because we looped through them one by one and we assigned that value to fruit. So it was locat, then jujube, then it was pear, then it was watermelon, and finally it was apple, and it was nothing else. So its value is stored in memory over there. So that's pretty much it, and just let's get rid of that with a, there we go, that's disappeared now. And we are going to run through our nested for loop. So we're going to do the same thing. So I can steal this little piece of code to start with, which is for fruit in fruits, and then beyond that we're going to do for color in colors. Again, this is a very standard pattern of a nested for loop in Python, and then we're going to do the same print, but this time we are going to do fruit. So we're going to print out our fruit, and we'll print out our color. So just like that, and we could switch them around depending on what we wanted to do, and we can just run this little piece of code, and we can see that we get a locat which is brown, a locat which is orange, a locat which is green, a locat which is pink, and a locat which is purple. And then we're going to cycle around that again. So that's all of our locats over here, and each one gets one color, and then we're going to get all of our GGBs, and then we're going to get all of our pairs, and so forth as it goes on. So that's the purpose of a nested for loop. I will get rid of all of this stuff over here, and we'll move on to our next block of code, which is basically indexing with enumerate. So this is a very useful feature. A number of languages has it. Python offers this. Again, we remember that we've got our lists already stored in memory, so all we actually have to do is for, and then this time we're going to put our iterable value, and then fruit. And this is kind of like this enumerate. We'll see when we actually get to the actual function, because we're about to do it, but it splits the list out into its index value and also its index item. So we'll see what that actually means. So in enumerate, because we can literally hover over it or see it in our, let's have a look. Oh, sorry, in enumerate, so just like that. And then we will enumerate over our fruits list, and our fruits list is this entire list over here. So we're just going to enumerate over that. So we can see by hovering over it that it gets the iterable. Well, we could start at a certain iterable point, but what it actually returns back, if we see it returns back if I don't know if I can keep hovering, but we see it returns back the index 0 and then sequence of item 0, and then index 1 and the value of item 1, and then the index 2 and the item of that's in the place of index 2. That's how the enumerate function works. So we can just put in our fruits list into here. Now the first index of any list is going to be 0, so n will be 0 for the first one, and the first fruit in our fruits list will be locat, so it should be 0 and then locat. In fact, I could write the index numbers. This is index 0, this is index number 1, this is index number 2, this is index number 3, and this is index number 4. So our list is 5 elements long, starting at index 0 over there. And we are going to be able to loop through each one of them, and we'll see exactly how it looks. So let's just actually just run that. So we will print, so I meant to put a colon over here and a print, and this time we're going to print the index value, which we've called n. We could have called it I for index and then fruit. So we're literally going to do that, and we'll see what comes about. And we get 0 locat, because locat was the first index, 1, which was the next index, is jujube, then 2 is pear, 3 is watermelon, 4 is apple. So that's the output of that piece of code. So what else can we do? We can elaborate on this, but with another piece of code, which is we can do the exact same thing over here, which is for n and fruit in enumerate fruits. So we can use our enumeration in the same way, but this time we can use the indexing. So we can use, I will say this, let's use, I should have put a hash there, so use n as an index of colors. So what does that actually mean? Let's try and do it. We are going to print, this time, colors. So colors, so colors, and we are going to take the nth item of it, and then we will do fruit. So that's what we're going to do this time. Now all that this is doing is calling the nth item of the colors list. So for example, if we called index number 0, we would get brown, and if we called index number 1, we're going to get orange, and index number 2 green. So we can see all of a sudden that we can access both of the values from each list. The first one, we're just accessing it by value, and the second one, we're actually calling its index, we're using its index to extract its value. So let's just run that and see what we actually get from that. And there we do, we get a brown locat, an orange jujube, a green pear, a pink watermelon, and a purple apple. Okay, apples don't come in purple, but that's it. Now, we can extend this one more, because we can do this in a nicer way, which is using the built-in zip function. So there's a function that is built in that joins lists. So whilst this enumerate is quite nice, and we can do it via indexing, we can use a built-in zip function, and the way that we do that is with the same for loop, and this time we'll say item, and then in, and then zip, and then we're going to zip the two lists up. The two lists that we're going to zip is the fruits list and the colors list, and that will be it. So there we go, just like that. And we can print our item. Now we don't have to use item, let's spell it right, item, like that. We don't have to use the word item, we can use like I, so we can say for I in that, and we'll get the same thing. So let's actually do this. We will use item just for the sake of it. And these two lists will now be zipped together, almost like you can imagine a zipper, which is probably where the zip function was named after. So this one's going to be combined with that. This one, I'll actually draw it with the actual pen. So these will be combined as a pair because they're going to be zipped together. These two are going to be zipped together. These two are going to be zipped together, and so forth. These will be zipped together, and finally these two over here will be zipped together. And the zip kind of like we can see that it needs to be of the same length. If they were of different lengths, maybe we would have an error. Go and check it for yourself. So let's just run that and see what we get. And indeed we get a locat which is brown, we get a GGB which is orange, we get a pear which is green, a watermelon which is pink, and an apple which is purple. Now notice the difference between these two. We can see brackets and quotations around it, which is basically what we're getting back is a list of tuples over here. So, and in fact when we hover over it, it says here yield tuples until an input index is exhausted. So until we get to the end of our list, effectively it just returns back these tuples. And we could zip more than one list together, and I could do that. For example, let's just make a third list. I don't know what list we could make, but sizes. Right, we'll make a sizes list, and we need to have the same number of elements. So let's initially just start these all at and then we could put their sizes in like centimeters. So for example, this could be a locat. I don't know what size a locat is, 10 centimeters. A GGB could be 15 centimeters. A pear could be 7 centimeters. A watermelon, well, that's quite large, I don't know, say 25 centimeters. And finally an apple will be the same size as a pear, so we could say it's also 7 centimeters, like that. And we could then do a further zip. So we could do, let's just use using the built-in zip function, and we say extended. We can do pretty much exactly the same thing. So we can copy all of this code out and paste all of the code in here, and we could do our sizes list like that. And this item is going to be sequentially each one of these items in the actual list. And if I scroll back up to the top of the list, and so like drew a line between them maybe, but these are the first item over here. These ones are the second item. I have to draw it like that because my numbers are much smaller. This will be our third item at number 7, and so forth. We get the pattern of what it looks like. It should combine it if the zip function behaves the way that we think it should do. And let's just run it and see. And we get the sizes is not defined. So let's just go and have a look. Name sizes is not defined. That's because I need to rerun this block of code for it to be initialized. So there we go. Now sizes has gone into our memory. Remember, our memory was here. So sizes was never initialized because we haven't run that. So let's just remove that piece of memory and just try and run it again. And now it's in the memory. We get a locat which is brown, which is of size 10. So that's basically all of this little section here, which is all of looping over multiple iterables at once in Python. It's pretty simplistic but very powerful and very useful. So if you found this video helpful for yourself, hit the thumbs up button, the like button, and the follow button. And even if you didn't find it useful and helpful, still hit the thumbs up button, like button, and follow button. And thanks for watching. Looping over multiple iterables at once in Python.